Hello there, my name is Ajiboye Isaac. Today we want to continue from our previous lesson on surds and a specification on rationalization. Okay, so in our previous lesson we had discussed the basic rules of surd, similar surd in their basic form, addition and subtraction of surd using the knowledge of the similar surd, and how to simplify surd form. So today we want to look at how to rationalize a surd. We already said that a surd is irrational. Okay, and so we want to turn the irrational to rational. That is the meaning of rationalization. So our learning objectives at the end of the lesson, learners should be able to give the conjugate of a surd, rationalize a surd, rationalize the denominator of a surd, and use the idea of rationalization to simplify surd. Those are our objectives. Key vocabulary words: rational number. Rational numbers are numbers that cannot be expressed as a fraction. That is, number that cannot be expressed in the form of a over b. E.g., 6 over 2 is a number that can be expressed in the form of a over b, I meant to say. E.g., 3 is equal to 6 over 2. So any number that you can put in the form of a over b is a rational number. 5, it can be expressed as 10 over 2. Okay, so that means 5 is a rational number, right? Irrational numbers are numbers that cannot be exactly expressed as a fraction. Example of such numbers are roots of prime numbers. They cannot be exactly, you will see that their decimal part or their fractional part seems to be unending, and that is why they are irrational. Okay, so we have square root of 3, cube root of 7, and so on. They are all irrational. Rationalization: to rationalize a surd simply means to turn it into a rational number. Okay, you want to rationalize a surd means that you will turn it into a rational number. That's what we mean by rationalization. Learning objective: at the end of the lesson, learners should be able to give the conjugate of a surd. I think I've stated that before. And then rationalization and conjugate. Rationalization of surds. Surds are irrational numbers and can be turned into rational numbers. This process of turning a surd to a rational number is referred to as rationalization, as I have explained earlier. This is done by multiplying a surd by itself to get its square. Okay, because of the square root, to get rid of the square root, you square. The opposite of square root is square. So if you can multiply a square by a square, you get, a square root by a square root, you get a square root square. So the square will therefore cancel out. So for example, to rationalize the root of surd or the square root of 3, we do root 3 times root 3. That will give us root 3 all squared. And the square will cancel the square root, and then we'll get 3. And that's as simple as rationalization can be. On the other hand, we could have binomial surd. Okay, so to rationalize a binomial surd now is not different. Okay, to rationalize binomial surd, we multiply by its conjugate. We cannot treat binomial. What do you mean by binomial surd? A surd that has 2 terms. Like the root 3 now is monomial surd. That is, it has only 1 term. But you can have 1 plus root 3. That is binomial. You can have root 2 plus root 3. That's binomial because there are 2 terms in those surds. All right, so you bear in mind that the way you rationalize a single surd is not the same way you rationalize a binomial surd. All right, so to rationalize a binomial surd, we multiply by its conjugate. So the conjugate surd: two surds are said to be conjugate if their products give a rational number. I'll say that again. Two surds are said to be conjugate if their product give a rational number. For our knowledge of difference of two squares, we know that the square a squared minus b squared is equal to a plus b, open bracket and close, a minus b, open bracket and close. You can see there that we'll be multiplying two things, and they are also binomial. They are also binomial. So if you are multiplying two binomial surds, you can therefore get the square of the square root and the square of the other square root. And so we have a rational number at the end of the day. So this application of difference of two squares is very important in rationalization. Each time you are multiplying binomial conjugates, you can consider it as difference of two squares. I'll say that again. Each time you multiply conjugates of surds, you can consider it as difference of two squares. For instance, square root of the square root of a plus the square root of b. The conjugate will be the square root of a minus square root of b. I'll say that again. Square root of a, or surd a plus surd b. The conjugate of surd a plus surd b is surd a minus surd b. The conjugate of surd a plus surd b is surd a minus surd b. And so if you are multiplying both together, you therefore get it appears like difference of two square. And so you get surd a square minus surd b squared. And so the square will cancel the square root, or the square will cancel the surd, and therefore you have a minus b. So we can go from left to right, and we can go from right to left. Bear in mind, okay, the conjugate of a plus surd b is a minus surd b. I'll say that again. The conjugate of a surd b is a minus surd b. So if you are multiplying both, that is, you are multiplying a plus surd b minus a plus surd b times a minus surd b, you therefore get a squared minus square of surd b, which already suggests difference of two squares, and that will give us a squared minus b, because the square and the square root will cancel out on the b. So meaning the conjugate of a plus surd b is a minus surd b. Also, the conjugate of surd a plus surd b is a minus surd b. Rationalizing the denominator. It is more cumbersome to divide a rational number by a surd. It is therefore advisable to rationalize the denominator for more exact approximation. What that simply means is that we don't usually allow surd at the denominator. So whenever you are working in mathematics, you're solving a question in mathematics, and you have a surd as denominator, you will therefore need to rationalize the denominator. Do not leave your answer that way unless you have rationalized the denominator, because it is more cumbersome to divide a rational number by a surd. Okay, so in general, a over surd b is equal to a over surd b times surd b over surd b. The process there is called rationalization of the denominator. You see that in the end, you get a surd b over b. By so doing, we started with surd b as denominator, but now it is now b. We have ended up rationalizing surd b to become b, and that is the word rationalizing, okay, the denominator. So we have succeeded in rationalizing the denominator in that example. Don't forget that we can as well have a binomial surd, and therefore we also need to rationalize the binomial surd as denominator. So in that case, we will multiply by its conjugate anyway. We multiply by its conjugate. So for example, also if the denominator is a binomial surd, we can rationalize the denominator by multiplying by the conjugate. For example, a over b plus surd c is equal to a over b plus surd c times b minus surd c over b minus surd c. That b minus surd c is the conjugate of the denominator b plus surd c. Alright, so what we are doing there is that we are multiplying by the conjugate, just so that we can rationalize the denominator b plus surd c. And so if you do that, what you will get will be a into bracket b minus surd c close bracket over open bracket B plus sort C, close bracket, and then times the conjugate. In the end, what you will get will be A, open bracket, B minus sort C, close bracket. Then you have the square of B minus the square of sort C. And the square of sort C will give you C, by the way. So that is why the final answer or the final expression will be equals to A, open bracket, B minus sort C over B square minus C. Solve the example. Simplify. 6 over root 3. You can see that we have a surd as denominator. So we cannot leave it that way. We have to simplify. We can still simplify further. And the only way you can simplify further is to rationalize that denominator surd 3. And how do we do that? By multiplying by the surd itself. So we have 6 over surd 3 to be equals to 6 over surd 3 times surd 3 over surd 3. And that will be equals to 6 surd 3 over surd 3 square. The square on the surd 3 will cancel the square root on the 3. Alright, the square on the surd 3 will cancel the surd. So we have our final answer to be equal to 6 surd 3 over 3. And 3 will divide 6. And that will give us 2 surd 3. Final answer. Alright, consider the example carefully. All you need to do is to multiply by the surd. In the case of a monomial denominator surd, alright, you just simply multiply by the surd, that's all. And then you get your simplified surd form. Let's look at the second example. Simplify 1 plus surd 5 over 1 minus surd 5. You can see that the denominator there is a binomial surd. Okay, so we have to multiply by the conjugate of that binomial surd. So 1 plus surd 5 over 1 minus surd 5 will therefore be equals to 1 plus surd 5 over 1 minus surd 5 times 1 plus surd 5 over 1 plus surd 5. Simply, that 1 plus surd 5 is the conjugate of 1 minus surd 5. So when you open up or when you try to expand, you get open bracket 1 plus surd 5, close bracket, then open bracket 1 plus surd 5, open bracket. And then at the denominator, you get 1 minus surd 5 times 1 plus surd 5. So already denominator, if you look at the denominator, like I've said before, it will be considered as difference of 2 square. So you square the first term and you square the second term. So that would be 1 square minus surd 5 square. All right. And then you open the bracket in the numerator. If you open the bracket, what you will get will be 1 plus 2 surd 5 plus surd 5 all squared. So if you simplify, you have 1 plus 2 surd 5 plus 5 because the square on the surd 5 will cancel out. Then at the denominator, you have 1 because square of 1 is 1 minus the square on the surd 5 will cancel the surd. So you have 1 minus 5. So that will give us 6 plus 2 surd 5 over minus 4, which in the end, you can bring out 2. You can factorize 2 from the numerator. So you have 2 into bracket 3 plus surd 5 over minus 4. And then you simplify. That is 2 will divide minus 4. So you have your final answer to become minus 3 plus surd 5 over 2. All right, minus open bracket 3 plus surd 5 over 2. So I wanted to take this classwork, attend this classwork, and forward your attempt to my WhatsApp number. Okay, don't forget the steps that we just look at the example carefully. Consider the example. It is not any different from what I have done. So what I have done in the example, listen to the explanation carefully again and do the same thing, repeat the same thing, and then it will become, the classwork will be a piece of cake, I believe. Then the assignment as well is not so different from the classwork or the example explained, right? So look at the assignment, attend the assignment carefully, take your time, attempt, and forward your attempt to my WhatsApp number. This assignment is due first thing tomorrow morning. I want to encourage as many of you that have forwarded your previous assignment and classwork. You're on the right path to success. Keep it up. Keep it up. You're on the right path to success. And then for more videos, go to Madzik YouTube channel. Okay, go to my YouTube channel, Madzik. All right, once you just type Madzik on YouTube, you scroll down, you see a particular Madzik, and then I have quite a number of notes there for you that could help you to understand mathematics better. Thank you for listening.